Hello everyone. So let's move on to the next session of wind energy. Today we can discuss about the basic components of wind energy conversion system. So in this figure you can see some basic components of wind energy conversion systems. Okay, so each important point we are going to study now. First of all, the aero turbines. You can see in the first block aero turbine or the wind turbine. This converts the energy of moving air into rotary mechanical energy. So you know that the wind energy conversion system, the wind energy system is converting the energy of air into first into mechanical energy and then into electrical energy. Am I right? So here the wind turbines at first convert the energy of moving air into rotary mechanical energy, right? Secondly, you can see the mechanical interface over there. The mechanical interface consisting of, you can see it here, the mechanical interface. The mechanical interface consisting of a step-up gear, you can see there, and suitable coupling transmits the rotary mechanical energy into an electrical generator. Okay, so you can see the electrical generator here. So the mechanical interface consisting of a step-up gear and suitable coupling transmits the rotary mechanical energy to an electrical generator. And the output of this generator is connected to a load or power grid. Okay, the output is connected to load or power grid, the output. Okay, then for the purpose of sensing, there's a controller provided with, and the controller serves the purpose of sensing the wind speed, the wind direction, shaft speeds, and torques at one or more points. Okay, then the output power and generator temperatures as necessary, the appropriate control signals for matching the electrical output of the wind energy input. Sorry. To protect the system from extreme conditions brought about by strong winds, electrical faults, etc. Okay, so the controller serves the purpose of sensing the wind speed. So the electrical power is generated according to the wind speed. Okay, we know that at every time the speed of wind will not be the same. Sometimes it may be of a lower speed like a breeze, or sometimes it may be of a very high speed wind. Okay, so the controller serves in sensing the speed of the wind. Then again, that senses the direction of the wind, right? And the speed of the shaft and torque. Torque എന്ന് പറയുന്നത് torque is the force acted by an object which is having a rotational motion. Okay, that's physics. Hmm? So the wind controller again serves the purpose of sensing the wind direction, shaft speeds, and torques. Then it senses the output power generator temperature. Okay, output power, generator temperature, etc. Then for the appropriate control signals for matching the electrical output of the wind energy input. Okay, according to the uh, output that we get, It gives appropriate signals. Okay, then for protecting the system from extreme conditions brought about by strong winds or electrical faults, etc. If the wind is very high speed, or if there is an electrical fault, the controller sends that problem and protect the system. Okay, so now we have the advantages and disadvantages of wind energy conversion system. So first of all, we can check some advantages of WECS. Some of these points I think all of you are already aware of. Firstly, the wind energy can be tapped free of fuel cost, isn't it? It does not need any fuel. The wind is rotating the uh, rotors and we are getting energy. So there is no need of an extra fuel, right? Then the wind energy turbine generation produces electricity which is environment friendly, right? See, you can compare it with the case of nuclear power stations. It's not at all environment friendly, right? So that comparison makes sense about this point. Then we have the wind power generation. It is cost effective, not much cost. Then economically competitive with other modes of power generation. See, the nuclear power plants, etc., are of having high, needing high, what is economical sources, right? Then it's quite reliable. Then electric power can be supplied to remote, inaccessible areas. See, you know that the wind farms can be uh, set on remote areas where there's no huge buildings, no thick forest, etc. So there should be uh, an environment in which the wind can easily flow. And that type of land, that type of area, always we can see in the remote areas. Hmm? So if in a remote area we set up a wind energy farm, obviously uh, it it serves the purpose of electrical energy need of that particular area. Okay, see, let's move to the disadvantages of WECS, wind energy conversion system. See, as the wind speed is variable, wind energy is irregular, unsteady, and erratic. I've already discussed this point. Wind speed is variable. We cannot expect the wind to blow with the same speed throughout, right? So obviously that is a disadvantage. Then the wind turbine design is complex. You know that it has a very huge height, it has very huge propellers and all. Hmm? So the wind turbine design is complex. Then the wind energy systems require strong storage batteries which contribute to the environmental pollution. See, the generation does not produce the wind energy, does not pollute the environment, but that requires storage batteries which contribute to environmental pollution. Okay, now the wind energy systems are capital intensive and needs government support, right? It's capital intensive. In order to set up at first, it needs huge capital. Then wind energy has low energy density and normally available at only selected geographical locations away from cities. Okay, we have already discussed that point. Then in wind farms, connections to state grid is necessary. Okay, only the generation of electricity and use of it is not sufficient. That should be connected to state grid, right? Then large units have less cost per kilowatt hour but require capital intensive technology for the large units of wind farm. It needs capital intensive technology, but it will have a comparatively less cost per kilowatt hour. But instead, small units are cost effective but have higher capital cost per kilowatt hour. Right?